All right, welcome back. Here we are, Module 6. Now, this one's going to be light and easy, similar to Module 5. In this initial semester, summer semester, we've got 3 modules all within the same week. So I don't want everybody to get loaded up. It's a full term course. It's more spread out. Got a couple of easy weeks. So, in this module, we're going to talk about some basic .NET types. And it's, well, wait a minute, what are you talking about types? Data types. Classes that exist for the C# language that allow us to create instances of a string, date time, an enum. All right. Well, we've got those. We've got a character. We already know from Module 2 and Module 3, we already know what a character is. Now we're starting to realize that, wait a minute, there's a whole lot going on that we may not have known about in other languages. We may not have been exposed to it. I know what a character is. A, B, C, uppercase, lowercase. How about just a space? A number? That could be a character. Now, in the char class, so when we say system.char, or we just call it char, that's the class that we're talking about, and it's in there in our system, in the .NET framework that we're using. All of them will have char. And now we're dealing with these things that it's an instance of char that has so much more going on. System.char, oh, we've got a toUpper method built in there. Here we've got is white space. So we've got a lot that we can go through and do, and how we do it, we can be explicit or implicit. I can go about it this way, and I'm pointing straight to system.char. If I said using system up in my header, I implicitly get char in. So I can say console.writeLine char dot, and now I get access to that method that's built into it. I pass it a \t. Boom. That's true. So there's functionality that's built in. 2 ways, and I've said it before, 2 ways to do about the same thing. I could have said char dot to lower C, and it would have worked. So similar to what we got here. Here's implicit, explicit. It's implicit because I did using system. So we've got all these static methods. They don't change. They do the same thing every time that we use them. Is it a digit? Is it lower? Is it upper? True, false. So we're getting back. True, false. I've got a string class, and in this string is immutable or unchangeable. We've got to use a method. If we want to go modify it, we've got to use a method to get into it. But with this, here's our string, hello. It's a character, array, or that's what we say, it's an array of characters called CA, and I passed it this string of characters, and I'm converting each one of those characters to an array. So I can modify the data type from a string, which is a string of characters, to, we say, a string of characters here, or an array of characters. So I can have null strings or empty strings, there's nothing in them, and walk through that. We've got the ability to go through and search the string, so we've got functionality that sees if a string ends with something. So here's the string. Does it end with Fox? It goes through and looks, returns a value, true or false. Does it contain this? It goes through and does the legwork for us. Does it contain Brown? Yes, it does. So all of these different little built-in methods, we have the ability to go through and use them as needed. What's the index of these characters? 0, 1, 2. So where do they start? At the index of 2. Index of any. So we've got a bunch of different methods available to us that we can use to interact with this string or array data type. So depending on the class that we're dealing with, we have the ability to use the built-in functionality to perform work. I don't need to recreate the wheel. Somebody else has already created code or methods to perform the task. I just need to know how it works. Not the details of it, but what it does, what's it need from me, and what's it going to give me. And then I can just invoke it. And that's what we call that, is invoking the substring method. Now, this is a string literal constant. It could be a string variable. Both of them are treated the same way because when it sees these quotation marks, it knows that is a string. Okay, now, joining strings together, we have that symbol right there. And they say, well, that's the plus symbol. That's for addition. You add numbers, but you concatenate strings. Think of it like two train cars, and you connect them together. Boom, boom. Now they've become one in how they're handled. If I took word plus the pipe symbol, which is treated as a string the way it's written, I could store that in a string variable, say words, store it in there, I'm good. Words, we took this string of characters, The characters are both letters and spaces, upper and lower. We took each of those values and split them apart and stored each word in the words string. So I can use that split function to break up a string. I don't have to use that plus symbol, which is what we use to concatenate. I can do it with a concat method that takes those, you put a comma in between them, each of the strings, and it also adds in a space. When you concatenate, it'll add a space in there for us. Or, no, this one, there's no space being added in on the concatenate. I misspoke. If I said to print and I sent it like this, it would put a space in it. So we would have two spaces, the one that's existing here and another one. The fact that we're using the concat method does not add an additional space in there. And that's one of those things, depending on the language, they'll treat these things a little different when you go to concatenate strings or use print functions or write line functions, whatever function or method I should say that we're using to perform that task to output to a console interface. Now, this is pretty huge. Our string.format, that method allows us to format strings in a variety of different ways. Now, prior to the semester that I'm recording this, we had used a product from Cengage called MindTap, and over the years they required, when we went to format a string for output, and the string could have involved a dollar sign, whatever it is on how I want to display it. The formatting, they got really explicit about it. And it kind of threw me off for a little bit, and it threw the students off for a little bit. So what we see right here is just a dollar sign. They're not looking at money here. They're explicitly putting in that character? Or is it? And that's one of those things that we got to say, well, wait a minute, what's that symbol mean? So we see it here is this one looks at it as a string literal. I want them to be able to be modified. So we put this in there, and it's like, all right, it's a string literal, but I want to go ahead and use formatting to do this to it. Go into system, get date time for right now, and what is the day of the week right now at the time that I'm executing this code. And it'll take care of that for us. So I'm able to invoke this string formatting explicitly by doing this. Now, there's other ways that I can do it. Here's a way for me to format a credit limit as currency. how far out do I want the notation to be? Is it currency is going to have 2 decimal places, so our precision points go out 2 spaces. How are we going to deal with whatever we're going to deal with? And when we see right here, when we go to it, this is what we would do here. So we've got Mary, and then we pad 20 spaces, then credit limit equals, we got that, and then I pad 15, and then I've got that 500 converted to a string, so the number 500 converted to a string as currency. So there's where we see that $sign come in. Now, just mentioned Cengage and MindTap, and that it threw us a curveball, if you will. What it threw us was a requirement to be not specific to a given currency. Now this C currency is for US money. I can use globalization and be more explicit about this and say, look, I want to use globalization, and we're not just going to deal with C. I want it to, depending on the money that we're talking about, I may want it to be euros, francs, yen. I want the symbol to represent that currency, not just the dollar currency. Okay. So we globalize this formatting to a monetary string. Got functionality available to us via the comparison operator or equivalency operator. Are these 2 strings equivalent? Now, they say equals, and it's not equals. Equals is money. It should be equivalent. It's a comparison method. Okay. For whatever reason, they said, well, we can go through and we can use equals. And for decades, I've been telling people, it's equivalency. They're equivalent. Strings aren't equal. They're equivalent. And for whatever reason, when they wrote this library, they used equals and not equivalent. So with this, it's going to return a Boolean, true or false, if these strings, using string comparison, compare the 2, are they equivalent, using the equals method. All right. We've got a variety of different methods that we can use. I'm not going to dig deep into all of it. Alright, deal with date and time. Many of you that had me for Intro to Programming have dealt with date time. It deals with a system clock. It goes in, we create a date time object. It's already built into the system. I get date time offset, time span, date only or time only. And it comes off of, like I said, the system namespace. So I can go in and get whatever I need to find out what day is it today, how many hours, and I'm dealing with a data type, but it's not a string, it's its own data type, it's date time, and so I can use this date time class to interact directly with the system clock, or I can use the functionality built into date time to format data. Let's say it's a string or whatever, I format it as date time, or the different forms of date time. All right. Now, it could be day, month, year, second. I want all of it there. What is now? I want all of it. And depending on the methods that I use to format it, it takes us way down to milliseconds, whatever it may be. How far off are we from UTC or Greenwich Mean Time? What time zone are we in? Whatever it may be, there's so much that we can do within date time. We create an instance of date time. So it's a date time class that exists. I pass it a year, pass it a month, pass it a day. And now I have my variable that is storing that information. In that specific format. Okay, let's jump on beyond date times, because they go into a lot of depth relative to date time. Now you've got this resource that if you want to dig deep into it, you've got it available to you. Alright, so we dealt with formatting. We can also do what's called parsing. And parsing is a way for us to go through and look to see, character by character, what's in the string. Now, I may catch an error. It may throw an error when I try to parse. So when parsing, I do the try parse, and that allows us to go check to see if this can be converted into. So I'm going to parse this, and I want it to be an int. I want to typecast this string, parsing it character by character, and I want to convert it into an integer. Yeah, it's not going to happen. All right. I try it. It's going to fail. Here, it'll succeed, and we'll end up with 1, 2, 3 in success. Oh no, this is just going to return, let us know that we were successfully, if we tried, we could have parsed it, but we didn't store it. Can you parse it into an int? If we can, we're making it a Boolean, true or false. So we would have been true here, false here. So much like we learned in Module 4, try catch, let's be safe. If I'm going to parse, do try parse. That way I'm catching an error should something happen. Try format, try parse. So I got to always be thinking about the fact that what if this isn't the way I think it's going to be? And here's our culture info relative to a globalization that I was talking about. And they do this in Great British pounds, go English to Great Britain pounds, and there we see it. Currency for the UK. There's another syntax we could have used on this, but we're not going to dig into that with this. Like I said, it was confusing enough for students when we got hit with it blindsided by MindTap back in the day. So we've got strings that are numbers. We format strings as numbers, whatever the numeric format. It's a string, but we're displaying it formatted as currency or as a number or whatever it may be. We've got the ability to format as different types of numbers. Customize it however we want to go about it. We've got different styles available to the different types of formatting. And parsing again. And if we come down, they talk more about globalization. And this is what I talked about before, where I can use globalization. I bring that in. And I've got a variety of different formatting available by doing so. Okay. They deal with that way later in the text than we're going to get to. Now, we've got a math class. It's built in, it's static, it's in system. As long as we use system, we've got it implicitly available to us, as well as all the methods that exist within it. So there's a round method, truncate, floor, ceiling, min, max, absolute value. All of these mathematical methods built into our system namespace. So if we know they're there, we can use them. We've got random number generator. It's built into, depending on the language we're dealing with. It may be built into math, may be built directly into system. It depends on the language. With this, as long as I've got system, I've got random. That's a random number generator. In some languages, I may have to put the seed in to have the ability to duplicate each time. I randomly generate a number, but I want to be able to duplicate what's going on. And I can set the seed as needed. We talked about enums in chapter 3. And we enumerate through. Okay. Let's leave it there. This digs deeper into enums, and we don't need to. Comparison operators are the equivalent, not equivalent. And we had method when it came to strings where we could do that. There's an exception. We dealt with that back in Module 4. All right, let's leave it there. And I will see you in Module 7. We got good things ahead in Module 7.